NASA has finally released its first scientific images from the James Webb Space Telescope. This is a monumentous occasion and an amazing achievement for all the scientists, engineers, and other experts that have made this a reality. And the first images have not disappointed. So what's so amazing about these new images? And have they changed anything about how we view the universe? Let's discuss it. The James Webb Space Telescope is a masterpiece in engineering, but it didn't come cheap. The telescope cost $10 billion to produce. And in the end, it took 40 million work hours to build and took thousands of people from 14 different countries to complete. But it is truly marvelous. It can operate in the freezing temperatures of space, which can be maintained because its sun shield has an FPS of around 1 million. The telescope itself has an optical resolution of 0.1 arcseconds and has the capability to theoretically detect the heat from a bumblebee at the distance of the moon. The telescope is highly sensitive in the infrared radiation, which helps to bridge the gap between the Hubble and Spitzer telescopes. And for better stability, the telescope orbits around the Lagrangian point L2 of the Earth-Sun system, which basically means that it's a stable orbit around the Sun that is locked to the Earth, but just 1.5 million kilometers from the Earth. All of these things combined, with the larger size of the Webb telescope, make it one of the most sensitive telescopes that we have ever made, and promises to add a lot to our knowledge about the universe. Part of why the James Webb Space Telescope is so interesting is that it can look back further, closer to the Big Bang, which is one of its primary goals. Now, finally, we have the first scientific images from the Webb telescope, and they are pretty spectacular. First up on the new images from the Webb telescope is the deep field image of the SMACS, or SMACS, 0728 galaxy cluster. While this is a massive galaxy cluster, which is located around 4.2 billion years away, Webb's image itself is approximately the size of a grain of sand held at an arm's length. This image only took 12.5 hours to take and achieved depths of infrared wavelengths beyond that of the Hubble Space Telescope's deepest fields, which took weeks. This really demonstrates exactly how much more powerful the Webb telescope is. Just look at the comparison between the Hubble and the Webb images. The clarity and the detail of this new image is astonishing. Now, what do we see in this image? Well, the cluster itself in the center of the image is quite interesting, but the galaxies around it are more interesting. Due to the massive amount of mass of the SMACS galaxy cluster, it can be used as a gravitational lens to magnify galaxies that are further away and thus older. These are the distorted, elongated galaxies whose light is being bent around the other galaxies. And some of these galaxies are more than 13 billion years old. One of the great advantages of the new Webb telescope is that it can take spectra of the light coming in, which allows it to identify certain elements. Here you see a spectrum of one of these galaxies that shows that even 13.1 billion years ago, that these galaxies had hydrogen, oxygen, and neon in them. And likewise, the Webb telescope is able to take spectra of many different galaxies, allowing us to really start to probe the formation of these early galaxies and hopefully begin to understand more about the early universe. The next target was a planet orbiting a star in another solar system. WASP 96b is one of more than 5,000 confirmed exoplanets in the Milky Way and was discovered in 2014. It is located roughly 1,150 light years away and represents a type of gas giant that has no direct analogue in our solar system. It has a mass that is less than half that of Jupiter, but has a diameter that's 1.2 times greater and a temperature greater than 5,000 degrees Celsius. Additionally, WST-96 orbits extremely close to the Sun-like star, just 1/9 of the distance between Mercury and the Sun, completing one circuit every 3.5 Earth days. So what did we learn from the new images from the Webb telescope? Well, because Webb can measure further in the infrared, it is capable of measuring the chemical composition of gases with much greater detail. Here is the spectrum that they took of WST-96b, which detects water vapor in the atmosphere of this planet. This is something new. The transmission spectra reveals previously hidden details of the atmosphere. While this is not evidence of life, as the planet is pretty hostile, it is a very promising step towards future studies looking at rocky planets, where life similar to that on Earth could form. The next images come from the Southern Ring Nebula. This is a planetary nebula, which is an expanding cloud of gas surrounding a dying star. It is nearly half a light year in diameter and is located 2,500 light years away from Earth. The near-infrared images of this nebula are similar to what was taken by the Hubble telescope, but with significantly more detail, particularly in the dust cloud, where the dynamics of this movement are much more visible. But one important thing is that this is a nebula that has two stars in the center, but it is not easily visible. But when switching to the mid-infrared image, the stars become clear. The hot central star has blown off its layers and is making the nebula fluoresce brightly from the emission of its intense ultraviolet radiation, while the brighter star is in the early stages of the stellar evolution and will probably eject its own planetary nebula in the future. The dynamics of these two orbiting stars plays a large role in the formation of the gas clouds around them, and with the Webb telescope, we can start to explore these dynamics. The next target the Webb telescope looked at is truly fascinating: Stephan's Quintet. This is a grouping of several galaxies that formed a compact galaxy group, meaning that they are gravitationally bound to one another. This also happens to be one of the first bound galaxy groups that was ever discovered. Back in 1877, it was discovered by the French astronomer Edouard Stephan in the south of France. As a consequence, this is one of the most studied galaxy groupings. For instance, we are fairly confident that 4 of the 5 galaxies form a physical association. That is, that they are a true galaxy group and will likely merge with each other. An interesting observation in the 1970s revealed a mysterious filament in the emission in the radio band, which lies in the intergalactic space between the galaxies of this group. More recent insight into the nature of this filament has made scientists believe that this is a giant intergalactic shockwave caused by one galaxy falling to the center of the group at several millions of kilometers per hour. So what did we learn from the James Webb Telescope? Well, we can certainly see the galaxies in much greater detail, as well as the dust clouds from the collision of these galaxies. The scientists have also taken spectra of these galaxy cores. Using this information, we can start to unravel how galaxies interact and collide. This might help us form a better understanding of dark matter and gravity at these scales. Last but not least is images of the Carina Nebula. The Carina Nebula is one of the largest and brightest nebula in the sky, located approximately 7,600 light-years away in the southern constellation Carina. Webb revealed many emerging stellar nurseries and individual stars that are completely hidden in previous visible light pictures. Because of Webb's sensitivity to infrared light, it can peer through the cosmic dust and see these objects. Objects in the earliest rapid phase of star formation are difficult to capture, but Webb's extreme sensitivity, spatial resolution, and imaging capability can chronicle these elusive events. The observations made in this image of many different stages of star formation will help to shed light on these processes, where much is still not known. All in all, the James Webb Space Telescope is an amazing feat of engineering, and has already shown just how amazing it is. We will absolutely have more amazing images from this telescope in the future. If you like this video, you might also want to check out this video where I discuss how Mars became inhospitable billions of years ago. Thanks for watching, have fun, and see you next time.